Hello, welcome to this webinar. So this session will be around Speak, our open API to integrate origin servers, packages, encoders with multiple DRM platforms. I'm Lionel Brungier. I'm Director of Product Management for the Video Delivery Services, and I'm really happy to have this webinar today with Sam.
Hi, Lionel. I'm excited to be here and join you with this webinar. My name is Sam. I'm a Senior Product Manager with AWS Elemental, taking care of video delivery solutions.
Thanks, Sam. So it's going to be a rather short session today, but there will be a lot to cover. So first, we'll talk about some key terms. We'll do some vocabulary checks because we want to make sure that we all speak. Then we'll go a little more into details with the Speak reference architecture, how we can use Speak to integrate DRM platforms with encoders, with packages, with origin servers. One of the advantages why we want you to adopt the standard and why we see a lot of value for our partners and customers. And we'll have a few questions at the end of the session. If you have questions after the FAQ, there will be an architect lounge, so don't hesitate. You can ask questions to anyone there, and we'll have our solutions architects to help you and answer your questions. So first of all, a few definitions. So I will ask you, Sam, we'll be talking about encryptors today. What are encryptors, really?
Absolutely. So encryptors are encoders, transcoders, or packages. These are the components that would be using the doing the encryption of the content. So they obtain the keys from the DRM platform and they encrypt the content and send it downstream for consumption.
Right. So we'll talk about Speak. Speak is derived from CPX, right? What is CPX?
CPX is an industry standard by -IF. It's a specification that talks about a container that can be used for the key exchange. So Speak is a derivative, like you said, about that. And we use the CPX format of the key exchange. So the Speak payload that we exchange with our DRM platform follows the CPX containers specification.
Okay. And Speak, it's a single format for multiple DRMs. And I think that we have a way to differentiate those DRMs. And we use what you call the system IDs.
Yes. So the system ID is a unique identifier that is registered with -IF. So like you can see over here, Microsoft PlayReady, Google Widewine, these are the system IDs for these DRM systems, and these are registered with -IF. And these system IDs are used in the CPX document that Speak uses to signal the DRM system that's used for that encryption and content consumption.
And to perform the encryption, we need to have a way to identify what key is associated to what content, type of content, what VOD asset. How can we do that?
So the key ID is what we use for that. The key ID is, again, an identifier. It's not the key, but it's an identifier to connect, to identify what is the key that is used for that particular content encryption. And this is used by the DRM platform to match the content, the key that is provided for the encryption and has an ID, and the ID is used it's used as an identifier to identify what is that particular key for that exchange.
All right. And the last term we have on this slide is PSSH. What is PSSH?
Absolutely. So PSSH stands for Protection System Specific Header. This header comprises typically data such as the KID that we discussed about, the system ID, and all that information that is required for the content key exchange. And we put this in the header, and it's usually stored within the MP4 box. This is used for the common encryption format.
Right. Thanks, Sam. So first of all, what is Speak? It's an acronym. It's a very clever acronym, but what does that stand for?
Absolutely. So Speak, the acronym, as you can see here, it stands for Secure Packager and Encoder Key Exchange. The genesis of this whole idea of Speak was to create an abstracted and a standardized way for key exchange between the encryptors, which includes encoders, packages, and transcoders, and the DRM platform. So Speak is an open REST-based API specification that uses the CPX standard for the key exchange. So it simplifies the encryption, it simplifies the exchange between the encryptor and the DRM platform.
Right. So we were talking about DRM platforms. So why do we need DRMs at all?
Absolutely. So if you think about the content, how content is produced and consumed in the world, content protection becomes really crucial and vital, because there are a lot of high value content or assets that are created, and the DRMs or digital rights management is how we make sure that the content is protected and the right person to whom that content is intended to be consumed is consuming it within the right time frame or window. So the DRM is really crucial because it enables protecting content and making sure that the access is provided to the right person.
So for blockbusters, for premium sport events, we need to have a way to secure the content, and that's what we do with DRM systems.
Absolutely. And the other thing is the market coverage, right? So it can be used for live streaming of sporting events where high value sporting events like the FIFA World Cup, that content is protected and it is distributed to the right consumer or right end client so that they can consume the content. And this content protection helps both the content provider to protect their content and also to ensure that the end user has the right way to access and consume that content.
Right. So we are talking about the market coverage. What about the devices? If I want to have a service that will be deployed on Apple devices, Android devices, other set-top boxes, Roku connected TVs, how can I do that?
So there are multiple DRM technologies and multiple DRM systems. The widely used ones are Fairplay, Widevine, and PlayReady. So in a real world, when the content is created and it is distributed, we want a system where the content can be sent to multiple screens and across different platforms, and they can be consumed. So, for example, Apple HLS, which is distributed to Apple devices, uses Apple Fairplay as the DRM technology for content protection. So there is a lot of complexity in having multiple DRM systems or DRM technologies, and that's why we need to have a way for us to be able to protect the content and send it downstream to be consumed by multiple devices. So Speak, we will talk more about this in the next few slides, but Speak simplifies all of that integration and democratizes that whole content protection world.
It simplifies because it's a single API for all those Widevine, PlayReady, Fairplay, DRM technologies, plus all the DRM platforms we can address.
Absolutely.
Right. So I can see that Speak can be very helpful for a lot of people. So we will we can talk about encryptors. Again, all the encoders, transcoders, packagers, origin servers. But it's also very helpful for content providers and DRM platforms. So first of all, for AWS Elemental, we are selling encoders, transcoders, origin packages. How is that helpful for us to have just Speak as one unique protocol?
Absolutely. So like I mentioned, the whole genesis of this idea was it started as an internal project to find a way to simplify how our encryptors, which are encoders, packagers, and transcoders, integrate with DRM solution providers. So typically, we would do this through a custom API call, and this custom API call integration was unique for every DRM solution provider.
Yeah.
So if you think about it, there is an incremental cost of time and effort needed to do every new integration.
Yep.
So Speak simplifies that by having one single API, which is an abstraction between the encryptor and the DRM solution provider. So once the DRM solution provider has implemented Speak, the encoder or packager or transcoder can use the Speak format to communicate with those DRM solution providers. So some of the benefits that we have is it helps us remove all of that duplicate and redundant code. So it makes the application lighter. And it also helps us focus on the core functionality rather than spending effort and time in maintaining all of these custom integration code that is there within our encoders. So here's an example that I did a small analysis on one of our packages, and for every custom integration that we did with a new DRM solution provider, it took us about 4 weeks of effort to do that. So all of that incremental effort and time is saved because we have to only integrate once with Speak, and we can talk to any of the DRM solution providers who work with Speak, right? And it also helps us save a lot of testing time needed to test with different DRM solution providers. Once we're integrated with Speak, any DRM solution provider who works with Speak would work out of the box with that particular encoder.
Great. So that's something we've done with our products, but we want to open it up to any other encryptor, any other encoder, transcoder, packaging server. We'll provide tools to help other competitors, other vendors of products competing with us to make sure that this API is largely adopted, because it's not only for the encryptors, it can also be helpful for content providers.
Absolutely. So we have seen the benefit of doing Speak, and we want to open it up and make this as an open API specification so that we can transfer this benefit to other encoders, transcoders, or packaging products who wants to adopt Speak and simplify their key exchange mechanism.
And for the DRM partners, for the DRM platforms that are available, how is that helpful for them?
If you look at all of these DRM solution providers, we currently have 12 DRM solution providers who have integrated Speak, and Speak works with these 12 DRM solution providers, right? And the way it helps them is that it lowers the barrier of adoption. So once they are integrated with Speak, any encoder or packager who wants to work with this solution provider, they would work out of the box. You don't need to do any custom API integration.
Yes.
So the DRM solution providers save time in supporting all of that custom API integration work, and it helps them also in the business side of it, because anybody can easily adopt a new DRM solution provider once they're within the Speak platform or Speak protocol.
So to give a concrete example today, if one of the DRM vendors wants to integrate with Speak, they will immediately be compatible with Elemental Live, Elemental Delta, AWS Elemental Media Convert, AWS Elemental Media Package with just one integration. And all the other encryptors that would also implement Speak will be compatible at the same time.
That's right.
Right. So we are talking a little bit about the Speak ecosystem today. So today we have 12 partners that are already integrated and some other coming up in the pipe. It's really interesting because if you look at what the names we have on the slide, we have some very big names. So it's really, I love the fact that we have all those partners already onboarded with Speak. And again, it's just the beginning. We see more and more traction from other different partners. So the ecosystem is expanding, and we think it's going in the right direction, really. So let's get a little more into details, and let's see what would be a typical architecture diagram. So Sam, can you tell us a little bit where SPEKE would fit in the classical ecosystem for video delivery?
So this is a typical workflow or architecture system diagram of how SPEKE works. And if you look at this implementation, we have the encryptor which uses the Amazon API gateway as the tunnel or as the means to connect with the DRM solution provider.
So that is an example where the encryptor is in the AWS cloud. So we use a cloud, but that's also something we could do on-prem.
Right. So there are two models of doing this. So this is the cloud-based architecture. The other model, it initially started off as a cloud-based protocol, and we have extended it to also our on-prem solutions. So on the cloud, SPEKE uses API gateway and AWS IAM to authenticate with the DRM solution provider to obtain the keys. Right. So it uses the API gateway to communicate with to call the API of the DRM solution provider and to assign role and have a strong auth to authenticate into the DRM solution provider. In the on-prem model, we use the digest auth as the mechanism for authentication. So Speak has as an authentication model that protects the communication between the encryptor and the DRM solution provider. So we can look at, for example, this detail over here. We have an encryptor that uses the API gateway to call the DRM solution provider, and then it stores its protected content on a storage bucket, typically would be S3, and then it sends. This content can then be consumed by downstream players, and the player then communicates with the DRM solution provider to obtain the keys to decrypt and consume that particular asset.
Right. So if we want to get a little more into details and see what would be the interaction we have between the encryptor and the DRM platforms, can you give us a little workflow here?
Absolutely. So like we discussed earlier, SPEKE is the container that's used for requesting the key and obtaining the key back. So this whole exchange, if you see, there are two main parties in this. One is what we call as a packager here. It could be an encoder or it could be a transcoder. And it talks to a DRM platform, a DRM solution provider. And the first one is the origination of the SPEKE document, the version 1, in that it mentions a key ID.
So we start from the right. We start from the encryptor.
Right.
Then.
Yeah, so it sends the SPEKE document, and in the SPEKE document, it mentions the key ID, the identifier for the key,
right,
and the DRM system required for this particular encryption. So this request payload then is sent to the DRM system. So the DRM system gets that request, and now it knows what exactly is a key ID, and it knows what DRM system this exchange is for. Then it replies back with the content, the key for content protection, and again within the same, it uses the same container, the same SPEKE document, and it replies back in the same format with the key for the content protection. And based on whether it's a common encryption or if it's AES 128 fair play, it would send a PSSH value or a URI ext key with the keys and the other DRM custom data to the packager back. So the packager then takes that key that it receives from the SPEKE document to encrypt or scramble the content and send it downstream.
Okay. So yeah, I think that's clear. If we want to get even more into details, if we want to take a look at what would be a sample request, so that's the first request we would get from the encryptor to the DRM platform, right?
Yes. So this is a typical example of what that request payload would look like. And there are some key components, payload components over here that I would like to call out. So this tag, the content key tag, has a placeholder for the DRM system to put the key, so it's used as a container for placing the key.
Okay, so just a placeholder, and then you tell what's the key ID you want to use.
Absolutely. So the key ID signals what exactly is the content. It could either be a channel and a particular segment in that channel, or it could be a word asset, and there could be only one key for the whole word asset. So the key ID signals that.
So in that example, we have a system ID. So the system ID, that's what identifies if it's play ready or white vine or fair play.
Absolutely. So here, if you look at this is an example of a white vine and a play ready system ID.
So we have the same key ID, but we have two different system IDs.
Absolutely. And we also use this for multi-DRM format of encryption.
Okay, so that's a simple request to get the key that we want to perform the encryption with, and the response would be something like this.
So this is the version 2 of that block diagram that we saw earlier, if you remember. So this would be the response payload.
Okay.
So the DRM solution provider inserts the key or places the key back, and then it responds back to encryptor, and it gives a key. And here there is the key ID, the system ID. And then the other important piece of information over here is the PSSH.
Right.
So the PSSH is used for common encryption. This is used for play-ready and wide-wine.
Mm-hmm.
So the PSSH typically has the key ID associated with that key, and then it also has the system ID and other DRM custom data that would be required for this exchange. So this response payload goes back to the encryptor. The encryptor then reads through the CPIX document, and it consumes that key, and it uses that key for encryption of the content.
So the encryptor would get the key and then produce the encrypted content and provide the information in the manifest.
So there are different ways the encryptor could choose to do that. If it could either place that information about the key within the manifest file,
mm-hmm.
or it could do it within a PSSH in the common encryption.
Okay.
It places all that information in a PSSH box and puts it within the MP4 box itself and sends it downstream. So the player can either look into the manifest, or it can look into the PSSH box in the MP4 segment,
yeah,
to know where to request the key from.
So in the case we want to have an example here with a dash manifest,
mm-hmm.
we can see that we would get the key ID and the system ID provided by the encryptor along with the fragmented MP4s that are encrypted with those informations.
Absolutely. So if you take this example, this is a dash manifest. So the player receiving this could either be an Xbox player,
mm-hmm.
or it could be an Android device,
mm-hmm.
right? So, or let's say that the Xbox player uses the play-ready
mm-hmm.
key, right? So the play-ready DRM system, and the Android device uses the wide-wine
mm-hmm.
DRM system. So both of them can receive the same manifest based on who the end consumer is and what is the DRM system. The player can choose which DRM system to use to obtain the key. So this is a multi-DRM signaling method where the content is produced once and the manifest is sent, and multiple devices can choose between different DRM systems. So it simplifies the whole video workflow, and that's how and Speak enables all of this in the background.
Yeah, that's great. So I think I'm convinced now. I want to get started with Speak. I want to implement my encryptor. I want to implement my own DRM platform. How can I get started?
So here are some links that you can go visit to get some information about what Speak is, more details on how the response payload and request payload looks like, and any other questions. We have a lot of information there that can get you started.
On the AWS website.
On the AWS
Everything
website.
is publicly available. You don't need
Yes.
to log in or whatever. You can get access to that just by browsing.
Yes, so it's completely open. And then we also have a GitHub reference server project where you can create a reference server that can interact with an encryptor. So this could be really helpful for anybody who wants to test their workflow even before they enter into a partnership with a DRM solution provider.
So same thing. This Speak reference server, it's available totally freely. It's open source. You can fork it. You can make modifications. It's something we give to the community, to the Speak community, to get it bigger and bigger.
Yes, and there's a lot of information there, and as you mentioned, Lionel, it's an open source project. So we have a lot of interest in this reference server project, and there are a lot of people who are actively involved in this. So it's a great starting point for anybody who wants to set up their own reference server, and they can look at the code that's available there and set up or spin up their own reference server.
But just to make it clear, it's not something that is production ready. We don't recommend to go in production with that.
Right.
It's just a tool that is given to the Speak community
Absolutely.
to help it.
So it acts as a starting point for you to try out Speak.
All right. So a few other links. If you want to get more information about CPIX and the -AF implementation guidelines, we've provided you the CPIX version 2.0, which is the version that was taken as basis for Speak. If you want to get more information about the DRM technologies, you can find here pointers to Widevine, Google Widevine, Microsoft Play Ready, and Apple FairPlay, which is basically, those are the three main DRM technologies used for OTT delivery. We've heard a lot of questions about Speak. So before finishing up this session, I just want you to answer some of them if we still have time. So first of all, can Speak be used for both live and VOD applications?
Yes, certainly, yeah. So Speak is built both for live and VOD workflows. So in the live workflows, we have a provision where we can do key rotations based on where the segment is, and so it's a configuration or implementation detail. But then we have the provision to do key rotation with the live workflows. With the VOD, typically the industry standard or best practice is to have one key for the whole VOD asset, static key for the encryption. So we have the provision to do that. So Speak can be fully used for both VOD and live workflows.
And the OTT world is moving so fast. There are new DRMs, new OTT formats all the time. So is Speak future-proof? Can we extend that with future DRM systems?
Certainly. So right now we have the big ones are FairPlay, Widevine, and PlayReady. But there are new DRM systems that are emerging every day. And Speak has the ability to be extended to add in new DRM systems and to extend Speak into providing support for those. So Speak is designed to be extensible.
In the example we've taken here, we saw that the encryptor creates the key ID. So the encryptor does the association between the VOD asset, the live channel, and the encryption itself. Is that something that can be changed?
Absolutely. So the model that we follow is called as encryptor consumer model. But we allow Speak to Speak is designed in a way that the key ID can be overridden. So there are multiple use cases for this. So if the DRM system itself wants to maintain the state of the key ID and have a time-based key ID, and they have a logic to handle that, they can override the key ID, and that can be sent back in the Speak response. So in our AWS Elemental products, we are agnostic of the request and response key IDs. So if the response key ID is different from the request, we still use the response key ID.
Thank you. Can anyone integrate their key management system, their key platform, their DRM platform with Speak?
Absolutely. So
no restriction?
No. So as long as they're integrated with Speak and they can use the Speak CPIX container for the key exchange, you can create a reference server, and we provide that with our GitHub project. You can use that as a starting point to create your own reference, your own key server, and it can fully integrate with Speak.
Last question. How can we make sure that the communication between the encryptor and the Speak server is secured enough?
Absolutely. This is a question that we keep hearing a lot from the ground. So the way we secure that is, as I mentioned earlier in the presentation, we use AWS IAM and API gateway to create a strong auth on the cloud between the encryptor and the DRM platform, so that all that exchange happens in an authenticated manner, and so that whole communication channel is secured. On the ground, we use digest auth for a credential exchange between the encryptor and the DRM platform, so that both of them know who is talking and they can authenticate each other and have secure communication.
That's one of the differences also between CPIX 2.0 and Speak. With Speak, we provide a way of doing the authentication.
Right. So CPIX is an industry standard that gives a specification of how that payload can look like, but it doesn't give all the implementation details. That's why we call Speak as a derivative. It has derived out of that and has created a functional system or a model for that key exchange to happen.
Great. Well, thanks again, Sam. It was a very insightful session. I hope you all enjoyed it. We have other sessions available today, so please don't hesitate. Check out all the sessions. We have a lot of them, and they are all very informative, so you learn a lot. Don't be shy. go and get the other sessions. Also, if you have any question, you can come and visit the Architect Lounge. So you can ask questions, and we have a team of solutions architects. They will answer all the questions you have on Speak or any other session we have today. Thanks again. It was a pleasure having this webinar with you all, and see you soon. Thank you.
Thank you.